Chapter 1: Army Aviation's Role in Unified Land Operations. Section I: Unified Land Operations. Unified land operations involve offensive, defensive, stability or defense support of civil authorities tasks performed simultaneously. These tasks aim to seize, retain, and exploit the initiative to shape the operational environment, prevent conflict, consolidate gains, and win our nation's wars as part of unified action. Army Aviation integrates into these operations by conducting air-ground operations as the aviation maneuver force of the Combined Arms Team. These operations involve the simultaneous or synchronized employment of ground forces with aviation, maneuver and fires to seize, retain and exploit the initiative. Employing the combined and complementary effects of air and ground maneuver and fires through air-ground operations presents the enemy with multiple dilemmas. This increases combat power, mission effectiveness, agility, flexibility, and survivability of the entire Combined Arms Team. These operations ensure that all members of the Combined Arms Team, whether on the ground or in the air, work toward common and mutually supporting objectives to meet the higher commander's intent. Effective air-ground operations require full integration of aviation and ground maneuver as a Combined Arms Team. As a key component of the ground scheme of maneuver, Army Aviation achieves interdependence with ground forces through a shared understanding of the operational environment. An integrated or synchronized scheme of maneuver and fires, clearly defined triggers and conditions for employment. Shared understanding of the commander's intent, clear command and support relationships, and clearly defined roles and responsibilities that maximize the capabilities of each element of the Combined Arms Team, while offsetting the other's limitations. Although air-ground operations demand integration of aviation tactical tasks into the ground scheme of maneuver, this does not mean that greater planning times are always required. More detailed planning and rehearsals are necessary when the Combined Arms Team is newly formed. Agility, speed of action, and mission success are significantly enhanced when effective habitual relationships are established, liaisons are embedded throughout the operations process, procedures are standardized and practiced, a common operational picture is maintained, and mutual trust is built through effective relationships and shared understanding. Section II: Challenges for Army Aviation. Army aviation forces must be organized, trained, and equipped to meet worldwide challenges against a full range of threats. However, readiness to conduct large-scale combat operations, or LSCO, against a peer threat is the greatest challenge to our force today. These operations are incredibly demanding in terms of operational tempo and lethality. Every domain, air, land, maritime, space, and cyberspace, may be contested by a capable adversary who has likely invested significant resources learning from recent United States operations. State and non-state actors threaten with conventional and unconventional weapons, potentially including chemical, biological, radiological, nuclear, and high-yield explosives, weapons capabilities. The enemy also employs tactics which restrict freedom of maneuver through the use of advanced radar, infrared, and laser air defense systems. On the ground, support nodes and assembly areas are vulnerable to precision long-range fires, threat aviation, and improvised explosive devices. Army aviation must be lethal, survivable, and adaptable in order to provide combat power to the ground commander in large-scale combat operations. For more details, refer to Field Manual 3.0a. Current lethality challenges. Russian integrated defense in depth. Since Operation Barbarossa in 1941, Soviet and Russian military thinkers have valued area denial tactics. Emerging from World War I, Soviet deep battle doctrine required synchronization of precise ground and air fires, with maneuver to mass on critical targets at a decisive moment. Deep battle endured throughout the Cold War and continues to influence current Russian doctrine. Russia's current concept applies deep battle in a defensive manner to protect a critical asset in 3 dimensions. In practice, however, Russia's current approach employs not a single protective layer, but multiple mutually supporting capabilities. These include man-portable, short, medium, and long-range air defense systems, manned and unmanned aircraft, tube and rocket artillery, ballistic and cruise missiles, direct fire systems, and information warfare capabilities. The sum of these systems is an integrated network of combined arms capabilities designed to deter enemy attack or inhibit freedom of action from the tactical to the strategic levels. At the tactical level, integrated air defenses attempt to deter or defeat low-altitude rotary wing and unmanned systems operations. An integrated fires complex employs artillery systems for counterfire and fire support, and electronic warfare assets seek to disrupt enemy communications and operations. At the operational level, air defense systems employ a blend of short and medium-range missiles alongside long-range precision fires. Attacks target deep critical assets such as aviation headquarters, tactical assembly areas, and sustainment sites. Russia's intent at the operational level is to prevent brigade-sized elements from effectively concentrating combat power, resupplying, or reorganizing. At the strategic level, the Russian integrated defense in depth combines lethal and non-lethal capabilities to target major air and seaports, assembly areas, high-level headquarters, regional networks and communications, high-performance aircraft, and surface ships. Cyber and other information warfare elements attempt to disrupt operations or deny access to information anywhere in the theater through targeted or mass attacks. This multi-layered network seeks to deter enemy attack by presenting a prohibitively costly theater of operations. If deterrence fails, it seeks to impede an enemy force from ever organizing to challenge Russian actions. Section II. Core competencies of Army Aviation. As a fully integrated component of the Combined Arms Team, Army Aviation forces are organized, trained, and equipped to defeat a full range of threats. Army Aviation forces provide an asymmetric maneuver advantage through amplified reach, protection, lethality, and situational understanding. Army Aviation's inherent mobility, speed, range, flexibility, lethality, precision, and persistent reconnaissance capabilities provide the Combined Arms Team with multiple options to seize, retain, and exploit the initiative to gain and maintain a position of relative advantage. Army Aviation is unique in that, in addition to its ability to maneuver in the third dimension, it can operate in all 6 warfighting functions in support of commanders' missions and objectives. Provide accurate and timely information collection. The Army executes intelligence, surveillance, and reconnaissance through the operations and intelligence process and information collection. Information collection is an activity that synchronizes and integrates the planning and employment of sensors and assets, as well as the processing, exploitation, and dissemination of systems in direct support of current and future operations. A successful information collection effort results in the timely collection and reporting of relevant and accurate information, which either supports the production of intelligence or is disseminated as combat information. Army Aviation should be utilized in every step of the information collection, planning, and execution process. Effective planning for aviation capabilities may enable the Combined Arms Team to determine the enemy's intent and answer the commander's critical information requirements by observation or fighting for information as required. This enables the commander to confirm or deny an enemy course of action and concentrate combat power at the time and place of the maneuver commander's choice to seize or retain the initiative. Through the conduct of zone, route, and/or area reconnaissance, movement to contact, or reconnaissance in force when task organized, Army Aviation provides the commander with accurate and timely information on enemy force disposition, composition, strengths, and weaknesses. Army Aviation also provides information on population patterns of life, ground routes and mobility corridors, dense urban terrain and infrastructure, and man-made or natural obstacles to answer a commander's priority intelligence requirements. In addition to answering these requirements, Army Aviation's speed and flexibility provide a unique ability to answer friendly force information requirements for geographically dispersed forces, increasing shared understanding. Army Aviation attack and reconnaissance units conduct reconnaissance as a maneuver force with manned and unmanned systems maneuvering interdependently. Manned Unmanned Teaming, or MUMT, is the integrated maneuver of Army Aviation, rotary wing and unmanned aircraft systems to conduct movement to contact, attack, reconnaissance, and security tasks. MUMT enables increased depth and breadth of aviation reconnaissance and maneuver, increased persistence over the reconnaissance objective, increased ability to gain and maintain enemy contact, increased survivability, and more options to develop the situation, with enhanced maneuver, fires, and command and control. Army Aviation assault units may conduct infiltration and extraction of dismounted reconnaissance elements conducting detailed reconnaissance of designated objectives. They may also emplace remote sensors on key avenues of approach and terrain features, conduct route, area, and limited zone reconnaissance, evacuate captured enemy personnel for intelligence, exploitation, or conduct continuous resupply of ground reconnaissance elements to enable continuous maximum reconnaissance forward. The commander can task Army Aviation units and assets with the mission to provide multi-intelligence sensor data and information from manned and unmanned systems to the Army intelligence enterprise. Some examples of sensor data include full-motion video, synthetic aperture radar, moving target indications, and signals intelligence. To meet these requirements, Army Aviation units must be augmented with the appropriate communications capabilities to connect to the larger intelligence architecture. Signal and military intelligence units coordinate and augment Army Aviation units to establish the necessary communication connections and implement reporting procedures. Together, these units position the communication systems and processing, exploitation, and dissemination capabilities at the most effective locations to ensure sensor data and information are effectively analyzed across the Army intelligence enterprise. Provide reaction time and maneuver space. Army Aviation security operations provide the combined arms team early and accurate warning of enemy activities, reaction time and maneuver space to prevent surprise and rapidly develop the situation upon gaining enemy contact. Army Aviation attack and reconnaissance units perform security tasks as part of the combined arms team. They may operate as a sub-element of a larger combined arms security force, conducting screen, guard, cover, or area security tasks. When properly task organized, they may conduct screen or guard tasks as a separate maneuver force in an assigned area of operations. Employing MUMT enables the security force to expand the breadth and depth of the screen to maintain continuous surveillance of avenues of approach, locate lead enemy elements, and maintain enemy contact to enable increased early warning, reaction time, and space for the main body to develop the situation while preventing early deployment of friendly forces. As the situation develops, Army Aviation attack and reconnaissance units can quickly transition from the screen to conduct attacks to destroy or repel enemy reconnaissance and/or lead security elements with the necessary agility, long-range acquisition, and fires without becoming decisively engaged. Army Aviation units also support the consolidation of gains by conducting area security tasks for the supported commander. Destroy, defeat, disrupt, divert, or delay enemy forces. Army Aviation conducts attacks during the execution of offensive, defensive, and stability operations in support of the combined arms team throughout the depth and breadth of the area of operations. Army Aviation attacks to destroy, defeat, disrupt, divert, or delay the enemy, who may be either in contact or out of contact with friendly ground forces. Regardless of whether the enemy is in contact with friendly ground forces or not, attacks are executed as deliberate or hasty operations. Through the integration of MUMT to support attacks, Army Aviation extends the reach of the combined arms team through increased acquisition ranges, persistent reconnaissance, enhanced positive identification, greater capability to maintain enemy contact, greater lethality, precision targeting of high-value enemy capabilities, extended communications, and real-time battle damage assessment. When enemy forces are in close contact with friendly ground maneuver forces, Army Aviation attack and reconnaissance units attack to destroy, defeat, disrupt, divert or delay enemy forces to enable the combined arms team to seize, retain or exploit the initiative. The ground maneuver commander in contact is responsible for the detailed integration and synchronization of Army Aviation in the overall scheme of maneuver and controls the distribution and synchronization of Army Aviation maneuver and fires. Airspace coordination is required with the appropriate airspace control authority. When enemy forces are not in close contact with friendly ground maneuver forces, Army Aviation attack and reconnaissance units maneuver independently from ground maneuver forces to attack to destroy, defeat, disrupt, divert, or delay enemy capabilities before they can be brought to bear effectively against friendly forces. The Army Aviation Maneuver Commander controls Army Aviation maneuver and fires within an assigned area of operations, but the attack is still synchronized and/or integrated with the overall higher ground scheme of maneuver. Based on the complexity of the targeted enemy force and operational environment, Army Aviation attacks against enemy forces out of friendly contact are frequently higher-risk operations that require detailed planning by the supported ground maneuver headquarters for the proper allocation, synchronization, and integration of joint fires, collider-enabling capabilities. When task organized with adequate ground maneuver forces and fires, Army Aviation can operate as the tactical combat force in the support area to defeat level II and II threats. Army Aviation attacks against enemy forces in or out of contact with friendly ground forces can be the decisive or shaping operation at the tactical or operational level and may enable the combined arms team to maintain initiative or consolidate gains while presenting multiple dilemmas to the enemy. Air Assault Ground Maneuver Forces. Army Aviation conducts air assaults during offensive, defensive, and stability operations throughout the depth and breadth of the area of operations. Air assaults are combined arms operations conducted to gain a positional advantage, envelop, or turn enemy forces that may or may not be in a position to oppose the operation. At the tactical level, air assault operations emphasize seizing terrain, destroying enemy forces, and interdicting enemy withdrawal routes. Army Aviation assault and heavy lift units, supported by attack and reconnaissance units, rapidly reposition personnel and equipment to enable the combined arms team to strike over extended distances and terrain to attack the enemy where and when it is most vulnerable. Air assaults extend the tactical and operational reach of the combined arms team by overcoming the effects of terrain, achieving surprise and isolating, dislocating, or destroying enemy forces by rapidly massing combat power at the maneuver commander's time and place of choice. The Air Assault Task Force, or AAT, is the entire combined arms team conducting the air assault. The AATF commander, normally the ground maneuver brigade or battalion commander, whose subordinate echelon constitutes the main combat force, commands the combined arms team through all phases of the air assault. When task organized with ground maneuver forces and fires, an Army Aviation battalion or brigade commander can operate as the AATF commander. The Aviation Task Force commander, or a designated subordinate leader for air assaults below battalion level, serves as the air mission commander and commands the aviation forces through all phases of the air assault and follow-on ground tactical plan. The ground tactical commander is the commander of the largest ground maneuver force inserted during the air assault and assumes command of the ground tactical force in the landing zone and upon initiation of the ground tactical plan. Army Aviation attack and reconnaissance units utilizing MUMT conduct reconnaissance, security, and hasty or deliberate attacks against enemy forces in and out of friendly contact under the control of the Air Mission Commander during the assault. They may transition to the control of the Ground Tactical Commander upon initiation of the Ground Tactical Plan. When task organized with ground maneuver forces and fires, Army Aviation battalions, squadrons, or brigades can operate as the AAT FAIR. Army Aviation provides the combined arms team with the agility, mobility, lethality, and the element of surprise to rapidly mass combat forces and equipment, regardless of terrain, to seize the initiative by attacking enemy forces or seizing objectives to exploit tactical and operational opportunities and enemy forces when most vulnerable. Air movement of personnel, equipment, and supplies. Army Aviation Assault, General Support, Heavy Lift, and Fixed-Wing units conduct air movement of personnel, leaders, critical supplies, equipment, and systems during the conduct of offensive, defensive, stability, and defense support of civil authorities' operations throughout the depth and breadth of the area of operations. Army Aviation rotary wing aircraft conduct air movement using both internal and external loads. The supported unit provides pickup zone and landing zone control, load rigging, ground movement, and certification. Army Aviation fixed-wing aircraft conduct air movement with internal loads between improved airfields to move limited critical personnel and supplies in the area of operations, or area of interest. The loading and ground movement of critical supplies and personnel for fixed-wing operations is typically controlled and executed through the Arrival-Departure Airfield Control Group. Air movement operations can be conducted in support of a variety of operations, including foreign humanitarian assistance, foreign disaster relief, homeland defense, non-combatant evacuation, routine emergency resupply of combat units, movement of barrier materials and munitions in the defense, movement of fuel, ammunition, and personnel over extended lines of communications to support the offense, and battlefield circulation of key leaders. Air movement operations reduce risk to ground logistics units through economy of force, enable operations in areas with limited ground lines of communication, allow faster repair and sustainment of combat power, and support forward positioning of key leaders to exercise mission command. Evacuate wounded or recover isolated personnel. As a vital component of the overall health service support mission, medical evacuation provides the linkage between roles of medical care. Medical evacuation is performed by dedicated platforms, either ground or air, with medical professionals capable of providing timely, efficient movement and en route care of the wounded, injured, or ill. The Department of the Army is the sole component directed to provide intra-theater aeromedical evacuation in the patient movement system within the Department of Defense. Intra-theater aeromedical evacuation is conducted by Army Air Ambulance units in support of the Joint Force while conducting offensive, defensive stability, and defense support of civil authorities, operations throughout the depth and breadth of the area of operation. Army Aviation. Brigades and battalions provide oversight of Army Medical Air Ambulance units conducting intra-theater aeromedical evacuation, according to combatant commander priorities, the air evacuation policies, and Department of Defense directives. The speed, flexibility, and en route care capabilities of Army aeromedical evacuation provide health service support with more options in the allocation of medical treatment facilities by mitigating the effects of extended distances between points of injury and medical treatment facilities, or between medical treatment facilities, while maintaining a continuum of care. Aeromedical evacuation is a non-combatant humanitarian mission and is provided special protections under the law of war and the Geneva Conventions. Army Aviation Utility Heavy Lift and Fixed-Wing units may conduct casualty evacuation when required in support of the Joint Force during offensive, defensive stability, and defense support of civil authorities' operations. Casualty evacuation, as a secondary component to the patient movement system, is the unregulated movement of wounded, injured, or ill personnel using non-medical assets that are dedicated to or designated in support of casualty evacuation operations. Opportune use of non-dedicated platforms is the lowest level of casualty evacuation operations. In contrast to medical evacuation assets, casualty evacuation assets may or may not include the provision of en route care, depending on the availability of medical augmentation personnel and equipment. Casualty evacuation may include carry-on medical equipment to accompany medical personnel, but the equipment and supplies are dependent upon availability at the time of the mission. As a non-medical platform, casualty evacuation aircraft retain their legal combatant status in an area of operations. Therefore, use of these assets includes the acceptance of additional risk to the patient, who is a non-combatant. Without standardized equipment or en route medical care, casualty evacuation generally lacks the assurance of continuity of care when moving a patient to a medical treatment facility. Even with these limitations, casualty evacuation is an essential part of the overall patient movement system and may be the first step in moving an injured soldier from the point of injury. Medical evacuation and casualty evacuation support requires detailed assessment and planning to achieve an effective patient movement plan. Army commanders designate, train, and posture their units to effect recovery of isolated personnel. Personnel recovery missions are joint operations and may require the employment of the full range of Unified Action Partner capabilities before and during execution. Aviation units are often tasked to support the recovery of isolated personnel by transporting personnel recovery security elements or recovery forces during immediate, deliberate, or external supported recoveries. This support may also include aeromedical evacuation, attack, reconnaissance, unmanned aircraft systems, and command and control support assets to support the personnel recovery methods of unassisted, immediate, deliberate, and external supported recovery. Evacuation missions can be conducted in support of a variety of operations, including foreign humanitarian assistance, foreign disaster relief, defense support of civil authorities, non-combatant evacuation, and all combat operations across the range of military operations and conflict continuum. Evacuation and recovery operations reduce risk and increase survivability of the combined arms team while enabling greater freedom of action. Enable command and control over extended ranges and complex terrain. Army Aviation enhances command and control by enabling the maneuver commander to better understand, visualize, describe, direct, lead, and assess operations over extended ranges and in complex terrain. Army Aviation enhances shared understanding of the operational environment through execution of movement to contact, attack, reconnaissance, and security operations, accurate and timely reporting via long-range communications, dedicated command and control support platforms, unmanned aircraft systems communications, relay packages. Distribution of full-motion video sensor information, management of controlled airspace through air traffic services, employment of aviation liaisons, embedded aviation staff elements at brigade and above headquarters, and battlefield circulation of key leaders. Attack and reconnaissance units conducting movement to contact, attack, reconnaissance, and security operations. Reporting via long-range communications and full-motion video provide the maneuver commander with timely and accurate information to enable the commander to understand and visualize the terrain, friendly and enemy forces. Army Aviation liaisons and embedded staffs assist the maneuver commander with visualizing and describing how best to employ Army Aviation as a member of the Combined Arms Team. Use of Army Aviation dedicated command and control support aircraft enables the maneuver commander to position forward to visualize, direct, lead, and assess ongoing operations. Man-at-Unman teaming enables the maneuver commander to visualize and assess operations through timely battle damage assessment and detailed reconnaissance throughout the depth of the area of operations and across multiple domains. Section IV, Army Aviation and the Operational Framework. To clearly visualize and articulate Army Aviation operations, commanders apply the four components of the operational framework. This framework is a cognitive tool to develop shared understanding and describe the commander's visualization of how Army Aviation operates in time, space, purpose, and resources while considering the physical, temporal, virtual, and cognitive aspects in an area of operations, area of interest. The following 4 components of the operational framework do not limit any of the 7 core competencies of Army Aviation. Commanders assign subordinate units an area of operations for the conduct of operations. Commanders designate close, deep, support, and consolidation areas. Commanders establish decisive, shaping, and sustaining operations to articulate an operation in terms of purpose. Commanders designate and supporting efforts to designate shifting and prioritization of resources. Area of operations. The area of operations is a designated area that commanders are assigned to conduct operations. From this designated area, they assign subordinate units smaller areas of operations based on the commander's visualization of the operation. Smaller unit areas of operations are established with regard to the unit's ability to influence what happens within the area. Within the area of operations, commanders use control measures to coordinate fires and maneuver and organize operations. When task organized appropriately, Army Aviation battalions or brigades can be assigned an area of operations and serve as the maneuver task force headquarters conducting reconnaissance and security operations, or during offensive or defensive operations in an economy of force. Assigning an area of operations to an aviation unit streamlines aviation maneuver and enables detailed integration with supporting assets such as joint fires or fixed-wing aviation. When aviation units are assigned their own area of operations, they accept the following responsibilities for the duration of the assignment: time management, information collection, civil-military operations, movement control, clearance of fires, security, personnel recovery, airspace control, minimum essential stability tasks. Aviation units typically operate across the entire area of operations of the supported unit. Maneuver throughout the area of operations is governed by phase lines, airspace control areas, standard use Army Aviation flight routes, or other control measures which permit simultaneous operations and converging of effects against the enemy. If an aviation unit is operational control or tactical control to a supported maneuver force, the aviation unit operates within that unit's boundaries unless other coordination is made. The aviation unit develops air and ground plans in conjunction with the supported unit. If an aviation unit is not operational control or tactical control to a supported unit, it must coordinate not only airspace and terrain management, but also locations for forward arming and refueling points, command posts, and radio retransmission sites. Close deep support and consolidation areas. The close deep support and consolidation framework describes the physical arrangement of forces in time, space, and purpose. Operations in close areas are conducted within a subordinate commander's area of operations. These areas can be contiguous or non-contiguous. Operations conducted in close areas are usually against enemy forces in immediate contact and are often the decisive operation. Army Aviation executes air-ground operations in the close area as a member of the Combined Arms Team. Army Aviation can conduct all missions and tasks when operating in the close area, including movement to contact, attack, reconnaissance, screen, air assault, air movement, command and control support, and evacuation missions. Deep operations involve actions to divert, disrupt, delay, or destroy enemy forces and capabilities before they can be used effectively against friendly forces. They may set the conditions for success in the close area or enable future operations. Operations in the deep area might disrupt the movement of operational reserves, prevent an enemy from employing long-range cannon, rocket, or missile fires, or attack a high-payoff target. Enemy forces in deep areas are not necessarily out of contact in a multi-domain environment. Deep areas can also include the spaces between non-contiguous areas of operations or beyond the designated boundaries of ground maneuver units in contiguous areas of operations. Fire support coordination measures are critical considerations when planning and conducting deep operations. Aviation operations in deep areas may include attacks to destroy, defeat, disrupt, divert, or delay enemy forces or high-value capabilities that are out of friendly contact, using manned unmanned teaming or independent, unmanned aircraft systems, attack reconnaissance operations. Reconnaissance operations by manned and/or unmanned aircraft to obtain combat information to answer priority intelligence requirements on the terrain, enemy or civilian populations. Air assaults of conventional or special operations forces to seize an objective or key terrain or destroy an enemy force. Insertions of conventional and special operations forces to recover isolated personnel, emplace sensors, conduct raids, establish special reconnaissance positions, or to conduct partisan link-up. Recovery of designated personnel in deep areas. A support area is the portion of the commander's area of operations that is designated to facilitate the positioning, employment, and protection of sustainment assets required to sustain, enable, and control operations. In a contiguous area of operations, the support area extends from the rear boundary of the higher unit to the rear boundary of the next subordinate unit. In a non-contiguous area of operations, the commander designates the support area (UH-60). Army aviation operations in the support area typically include air movement, medical evacuation, and command and control support, but may also include reconnaissance, attacks, and security operations if there is a threat to the support area. When conducting attacks, reconnaissance, and security operations, Army Aviation typically operates as a combined arms team with the Tactical Combat Force. If properly task organized with ground maneuver or security forces, Army Aviation can operate as the Tactical Combat Force headquarters for the support area. The consolidation area is the portion of the commander's area of operations that is designated to facilitate the security and stability tasks necessary for freedom of action in the close area and to support the continuous consolidation of gains. During Operation Plan Refinement, the additional Army Aviation forces of the Combined Arms Team must be forecasted to conduct consolidation of gains activities. Army Aviation units in the consolidation area provide speed, flexibility, and increased freedom of action for the commander, thereby enabling decisive operations in the close area. Possible aviation tasks in the consolidation area span the entire range of core competencies, from attacks against bypassed forces to air movements, air assaults, or evacuation missions. While a core consolidation area is typically assigned to a division with an organic aviation brigade, a division consolidation area is typically assigned to a subordinate brigade that is supported by a battalion-sized aviation unit. Commanders must balance the amount of aviation forces assigned to consolidation missions with the need for concentration in the close and/or deep areas. Decisive shaping and sustaining operations. The decisive shaping and sustaining framework element lends itself to a broad conceptual orientation and defines the desired purpose of each component. Decisive operations are those that directly accomplish the mission. The decisive operation is the focal point around which commanders design an entire operation and accomplish the commander's intent. Army aviation forces are often used to increase the combat power applied to the decisive operation and conduct all missions in direct support, general support, tactical control, or operational control to the ground maneuver force tasked with accomplishing the decisive operation. Aviation operations may be designated as decisive. In this case, aviation units are typically task organized with ground maneuver forces as the combined arms team maneuver headquarters. Shaping operations are operations that establish conditions for the decisive operation through effects on the enemy, other actors, and the terrain. During unified land operations, Army Aviation conducts all missions and tasks in direct support, general support, tactical control, or operational control to the ground maneuver forces, tasked with accomplishing shaping operations. Army aviation units can also be assigned to accomplish shaping operations without ground forces. During these operations, Army aviation units conduct movement-to-contact attacks, reconnaissance, and/or screens to prevent the enemy from gaining a position of relative advantage. Finally, Army aviation can conduct shaping operations in support of the Joint Task Force and Air or Maritime Component commanders. Sustaining operations are those operations at any echelon that enable the decisive operation or shaping operations by generating and maintaining combat power. Sustaining operations occur throughout the area of operations, not just in the support area, and determine how quickly Army forces reconstitute and exploit success in large-scale combat operations. Army aviation conducts reconnaissance, attack, screen, air movement, medical evacuation, and command and control support when in support of a unit tasked with sustaining operations. Army aviation units typically are not sustaining operations headquarters. Main and supporting efforts. The use of main and supporting efforts provides prioritization of support and resources among subordinate units. The main effort is a designated subordinate unit whose mission at a given point in time is most critical to overall mission success. The designated main effort is typically weighted heavily with Army aviation combat power to achieve their mission. Army aviation units may also be designated as the main effort during specified phases of an operation when assigned as the maneuver headquarters operating independently from ground maneuver or task organized as the maneuver headquarters of the combined arms team. A supporting effort is a designated subordinate unit with a mission that supports the success of the main effort. Commanders provide supporting efforts with the minimum combat power necessary to accomplish the mission. Consequently, supporting efforts may be resourced with less Army aviation combat power than the main effort. Army aviation units may also be designated as the supporting effort during specified phases of an operation when assigned as the maneuver headquarters operating independently from ground maneuver or task organized as the maneuver headquarters of the combined arms team assigned as a supporting effort. Section 5. Operational Environment. To shape the operational environment, prevent conflict, succeed in large-scale combat operations, and consolidate gains, Army aviation leaders and units must be enabled with the training, leadership, and technologies necessary to accomplish the mission. Train leaders and formations that are fully capable of operating under ambiguous and often unknowable conditions, equipped with advanced technologies and capabilities, ensure that Army aviation remains a unique and asymmetric advantage for the Army and the United States. The operational environment is a composite of the conditions, circumstances, and influences that affect the employment of capabilities and bear on the decisions of the commander. The operational environment comprises many interrelated variables which include the physical domains, as well as the information environment, the electromagnetic spectrum, and other more cognitive areas, such as global or regional trend. The operational environment should be expected to be complex and dynamic, where aspects of it may be unknown and constantly changing. Additionally, the operational environment may be analyzed differently from the different levels of warfare. Some aspects of warfare continue to evolve based on missions, emerging technologies, or the enemy's capabilities, objectives, or resolve. However, Army aviation leaders should anticipate these changes alongside continuities such as the principles of war, the tenets of unified land operations, and Army aviation's core competencies. Commanders and staffs initially analyze an operational environment using the 8 operational variables. Leaders employing Army aviation forces must also understand the unique opportunities and constraints of aviation operations in the context of the threat and the multi-domain battlefield. Threat. A threat is any combination of actors, entities, or forces that have the capability and intent to harm United States forces, United States national interests, or the homeland. Within the operational environment, Army aviation can expect to encounter a wide range of threats. The intermixing of multiple threat elements, coupled with the operational and mission variables, create a complex and dynamic operational environment. Threats seek to disrupt Army aviation operations through terrain denial, air route interdiction, and intentional disruption of aviation areas of operations, such as forward arming and refueling points, landing zones, pickup zones, tactical assembly areas, and airfields. Threats can include nation-states, national alliances, paramilitary or military forces, and/or individuals or groups of individuals. When threats execute their intent to do harm to the United States, they become enemies. The diversity of threats across the land, air, maritime, space, and cyberspace domains to United States security and vital interests increases the need for Army forces to be prepared to conduct operations short of conflict as well as succeed during large-scale combat operations when required. Peer threats. Peer threats are competitors or enemies with capabilities to oppose United States forces across multiple domains worldwide or in a specific region where they enjoy a position of relative advantage. When preventing conflict with a peer threat fails, Army Aviation must be ready to penetrate enemy systems throughout the depth of the operational area to enable operational and tactical maneuver. This penetration and subsequent destruction, dislocation, disintegration, or isolation of enemy capabilities contributes toward the achievement of the Joint Force Commander's strategic objectives. These adversaries typically employ their resources to attack friendly vulnerabilities using various combinations of methods, including information warfare, preclusion, isolation, sanctuary, and systems warfare. Information warfare involves the use of activities such as cyberspace operations, electronic warfare, deception, or psychological operations to manipulate the information environment. Peer threats attempt to manipulate or distort information to present false narratives and disrupt friendly decision-making. Preclusion involves taking specific actions to prevent certain operations. This includes employing tactics and systems to prevent friendly entry into an operational area or to impede friendly freedom of action within an operational area. Isolation involves attempting to isolate friendly forces in various ways to prevent them from accomplishing the mission. This may involve physical actions or actions in space or cyberspace, such as denying mobility with obstacles or chemical, biological, radiological, nuclear, and high-yield explosives weapons, or preventing or limiting the flow of information. Sanctuary refers to putting threat forces beyond reach of friendly attack, using political, legal, and physical boundaries that restrict friendly freedom of action. Peer threats may exploit air defense networks, complex terrain, dispersion, international borders, or information to protect some or all of their forces for a specific period. Systems warfare involves attacking specific critical capabilities to cause failure in a larger friendly system, such as using electronic warfare to disrupt unmanned aircraft systems, operations, or chemical, biological, radiological, nuclear, and high-yield explosives attacks against ports of entry to prevent friendly forces from entering a theater. Peer threats to aviation include guided or unguided projectiles, anti-aircraft artillery, man-portable air defense systems, surface-to-air missiles, electronic warfare capabilities, cyber attacks, chemical, biological, radiological, nuclear, and high-yield explosives, and manned or unmanned aircraft. Peer threats present significant challenges to employment of any unmanned aircraft or manned aircraft above terrain flight levels. Some peer threat systems and techniques are described below. Anti-access and area denial strategies use long-range capabilities and systems to prevent the joint forces' penetration into an operational area, while area denial strategies seek to hinder subsequent operations within the operational area. Combined, these actions and capabilities create the effect of standoff, which prevents friendly influence in an area of operations. Peer threats employ multi-layered integrated air defense systems with long-range precision fires and other systems to challenge the joint force. Army aviation is particularly vulnerable to area denial tactics due to the requirement for large tactical assembly areas and sustainment nodes, and integrated air defense systems targeting aircraft during operations. Integrated air defense systems target aircraft during all phases of an operation. These systems traditionally employ anti-aircraft artillery or surface-to-air missiles. Anti-aircraft artillery systems provide the capability to fire exploding rounds of 20 mm or greater, which use visual, electro-optical, infrared, or radar for acquisition and ballistic solutions that can engage aviation systems up to high altitude. Surface-to-air missiles are short to long-range air defense systems using radar and/or electro-optical infrared acquisition and/or guidance. Surface-to-air missiles are capable of engaging all types of aviation systems up to high altitudes. Surface-to-air missiles are typically mounted on dedicated platforms, including stationary sites, wheeled or tracked vehicles, or maritime platforms. Surface-to-air missiles have the potential for employment as a component of an integrated air defense system, with supporting early warning and acquisition radars, providing cueing. However, some systems can operate autonomously with onboard acquisition and targeting guidance capabilities. Key to any integrated air defense system is the employment of an integrated radar network with the capability to detect incoming targets, and then employ the appropriate engagement platform at the lowest possible echelon. Man-portable air defense systems are shoulder-fired, point-defense guided missile systems using the infrared or ultraviolet spectrum with infrared, ultraviolet laser or optical guidance that can engage aviation systems. Man-portable air defense systems can be employed dismounted or mounted on ground vehicles, manned and unmanned aircraft, or maritime platforms, and are generally limited to the operator's ability to visually acquire and track aircraft before launching. Peer threat maneuver divisions typically employ man-portable air defense systems in a ratio of 6 launches per maneuver battalion, plus an additional 18 launches in the Air Defense Brigade. Response time of a man-portable air defense systems gunner can be significantly reduced if the systems are integrated into the integrated air defense system. Enemy aircraft, in addition to air-to-air capabilities designed to find and destroy Army aircraft, may be employed to attack aviation assembly areas, landing zones, pickup zones, and forward arming and refueling points, with aerial delivered fires to disrupt aviation maneuver and command and control across the area of operations. Unmanned aircraft systems pose additional unique threats, including reconnaissance and surveillance of Army aviation, ground and air operations, employment as improvised explosive devices against stationary and slow-moving aircraft or ground operations, and hazards to flight in congested areas, such as airfields and high-use air corridors. Cyber and electronic warfare involve disrupting access to space-based or internet-connected assets, including navigation, communications, and battle tracking systems. A space-based global positioning system provides critical information for all warfighting function information systems. Army Aviation employs numerous advanced systems, many of which may be built into aircraft or ground control stations. Other systems are critical pieces of command and control equipment in unit command posts. Peer threat capabilities to deny, degrade, or disrupt friendly access to information will greatly hinder the ability to maintain tempo by conducting command and control of dispersed forces. In addition to disrupting access to information systems, a peer threat may employ more traditional electronic warfare techniques such as mikoning, interference, jamming, or intrusion on radio systems. Units should utilize appropriate communication security methods to minimize susceptibility to electronic attack. For further operations in denied, degraded, or disrupted space operating environments, refer to Field Manual 314 or the Center for Army Lessons Learned. Chemical, biological, radiological, and nuclear weapons. Both state and non-state actors may employ these attacks as a method to deny access to a given area or to create mass casualty events for friendly forces. Recent proliferation of missile technology has enabled many states to acquire delivery systems which can deter action, deny access to specific regions, or strike friendly locations directly. Army aviation is particularly susceptible to these attacks given its large footprint, vulnerability when on the ground, and the increased risk conducting these operations and the difficulty in fully decontaminating aircraft after an attack. Anti-radiation munitions are active homing projectiles designed to detect and home on a radio emission source. Although initially intended for active engagement of emitting radar systems, anti-radiation munitions may be programmed and used to attack emitters employed on Army aviation aircraft. These munitions may be employed from threat rotary wing and fixed-wing aircraft, as well as ground and maritime surface platforms, to engage aviation systems up to high altitudes. Directed energy threats include laser designators, laser rangefinders, and missile guidance and beam-riding munitions. Directed energy weapons, to include anti-personnel, anti-sensor, and anti-material, use transmitted energy to disrupt, deny, or destroy an aircraft or aircrew member. The scope of directed energy weapons ranges from commercial off-the-shelf, handheld laser pointers to high-power, frequency acoustic and radio frequency transmitters. The employment of anti-sensor and anti-material systems is normally for point defense of crucial equipment or facilities with employment from vehicles or fixed positions. Hybrid threats. The term hybrid threat captures the complexity and blurring of the traditional elements of conflict. A hybrid threat is the diverse and dynamic combination of regular forces, irregular forces, terrorist forces, or criminal elements unified to achieve mutually benefiting threat effects. The hybrid threat employs traditional, unconventional, and hybrid strategies to threaten Army aviation operations in support of the Combined Arms Team. Hybrid threats to aviation may include improvised explosive devices, cyber capabilities, anti-tank guided missiles, passive detection, and directed energy weapons. Hybrid threats also seek to exploit constrained rules of engagement, weather and environmental limitations, multinational caveats, and other influencing political factors, while simultaneously disrupting friendly use of precision navigation and information networks. Coupling traditional and non-traditional threat weapons, hybrid threats constantly seek to adapt their tactics, techniques, and procedures to gain asymmetric advantages to overcome Army aviation's overmatch at the point of contact. Hybrid threats traditionally employ unguided weapons such as small arms, heavy machine guns, rocket-propelled grenades, and modified air-to-surface rockets against Army aircraft. These systems generally have reduced probabilities of hit against aircraft operating at higher altitudes in more permissive environments. Hybrid threats have fairly limited access to more sophisticated weapons, but may also employ anti-tank guided missiles, man-portable air defense systems, or anti-aircraft improvised explosive devices. Hybrid threats continue to seek low-cost commercial capabilities to disrupt or degrade communications, navigation, and precision munitions employment. In addition to commercial off-the-shelf adaptation, peer and near-peer threats possess specific capabilities dedicated to jamming and interference. Hybrid threat aviation capabilities may include military and civilian rotary wing and fixed-wing aircraft and military or commercial off-the-shelf unmanned aircraft systems. Hybrid threats may also target aviation forces on the ground with improvised explosive devices, direct fire or indirect fire. Multi-domain extended battlefield. Army forces conduct operations synchronized across multiple domains to converge the effects necessary to succeed during operations short of conflict, as well as during large-scale combat operations. Aviation operations are inherently multi-domain in nature, and Army aviation leaders require a thorough understanding of the operational environment to identify opportunities and risks related to their operations. Army aviation's ability to project power throughout the physical domains, as well as operate in space and cyberspace, is vital to joint operations. Physical domains. Army aviation must be able to fight under all conditions and in any of the physical domains as a member of the Combined Arms Team. Understanding and exploiting the unique capabilities presented by the physical environment, while mitigating risks and limitations, are essential throughout the operations process. Expeditionary operations. With regard to Army aviation, Expeditionary operations can be considered those operations that require rapid deployment of a task-organized force via land, air, and/or sea into austere and/or immature theaters with the requisite mobility, lethality, protection, sustainment, and command and control capability to operate as part of the joint, interagency, intergovernmental, and/or multinational team to conduct unified land operations against peer competitors in large-scale combat operations. Army aviation forces must be prepared to operate as part of the joint force and overcome anti-access and area denial capabilities to open a window of relative advantage. Specific considerations for expeditionary aviation operations may include mission sets. Aviation units must be ready to conduct the full range of decisive action operations up to and including large-scale combat operations against peer or near-peer threats. Duration. Units must be prepared to operate with limited external resupply and sustainment for days to weeks while conducting continuous operations. Unit of employment. The lowest echelon of employment is the company or troop, supported by a battalion or battalion task force headquarters. Operations timeline. Units must be prepared to conduct operations in support of the joint force within 24 to 72 hours of arrival. This time may be adjusted based on mission variables. Unit movement. Units must be prepared to relocate frequently throughout the conduct of operations for survivability and to remain engaged in the fight. Movement frequency is dictated by mission variables. Split operations. All units must be prepared to conduct split operations depending on mission variables and unit of employment. Mountain operations. Army aviation is ideally suited to conduct combat operations in mountainous terrain. Providing the combined arms team with increased mobility, speed, and range, Army aviation can effectively overcome the limitations imposed on traditional ground, mounted and dismounted maneuver in compartmentalized and complex terrain. Mountains provide visual and audio masking that may limit threat acquisition ranges, enabling aviation maneuver forces to achieve greater tactical surprise and protection from long-range observation and engagements. The use of air assault and air movement operations enable the combined arms team to rapidly reposition forces and materials at decisive points to retain greater freedom of action over the enemy, while achieving economy of force over large expanses of complex terrain with limited ground lines of communication. The mobility and lethality of attack and reconnaissance helicopters and unmanned aircraft systems provide ground maneuver forces with precise direct fire and persistent reconnaissance beyond ground, intervisibility lines, and in broken terrain, reducing enemy freedom of action and the likelihood of enemy forces achieving tactical surprise. Medical evacuation capabilities in remote locations with limited or no road infrastructure increase the combined arms team's survivability and freedom of action. Army aviation's over-the-horizon communication capabilities and ability to rapidly reposition ground maneuver leaders enhance the combined arms team's ability to perform command and control over extended distances and beyond line of sight. Operations in hot mountainous environments can limit aviation maneuver due to reduced load carrying capacity and maneuver power margins of aircraft. Depending on the severity of the altitudes and temperatures, trade-offs may be necessary between aircraft loads and fuel carried, as well as adjustments to tactics, techniques, and procedures, which can impact station time, maneuver in the objective area, landing zone and pickup zone selection, and aircraft ranges. Additionally, trade-offs may require additional forward arming and refueling point locations and/or more aircraft to complete a mission. Canalizing terrain reduces line-of-sight communications, may limit the size or freedom of maneuver of aviation formations, and can drive predictable flight patterns that can be targeted by the enemy. Detailed planning, varying mission timelines, choosing longer or multiple routes, and employing non-line-of-sight or communications relay packages on unmanned aircraft systems can mitigate canalizing terrain limitations. Several unique weather factors also influence operations in mountainous terrain. Unpredictable wind speeds, varying wind directions, and frequent up and down drafts, combined with high density altitude, low ceilings that obscure terrain, increased frequency of turbulence, and reduced nighttime illumination due to shadows and terrain masking of the moon or man-made light sources requires more detailed planning, more experienced crews, and adjustments to tactics, techniques, and procedures. Severe cold weather is also prevalent during the winter in mountainous terrain. Severe cold temperatures, snow, and ice increase time requirements for aircraft preparation and launch due to de-icing and snow removal, increased maintenance due to cold-soaked seals and electronics, and increased flight hazards due to whiteout, icing of blades and wings, and loss of visibility due to falling or blowing snow. Aviation operations above 10,000 feet, mean sea level for more than an hour, above 12,000 feet for more than 30 minutes, and above 14,000 feet for any period of time require the use of supplemental oxygen for all Army rotary wing aircraft. Additionally, depending on the height of terrain, unmanned aircraft systems service ceilings may reduce the height above ground for unmanned aircraft systems operations, which can increase their likelihood of visual or audio detection, compromising the ground scheme of maneuver, while increasing unmanned airity to engagement. Finally, all aircraft have weather restrictions as outlined in Army Regulation 95-1. Unmanned aircraft systems takeoff and landing operations may be especially limited due to weather patterns in mountainous areas. Desert Operations. Army Aviation provides the Combined Arms Team with enhanced capabilities to operate in desert environments. The extended sensor, communications, and weapons ranges of attack and reconnaissance rotary wing and unmanned aircraft systems enable long-range engagement of targets and collection of combat information to confirm or deny the commander's priority intelligence requirements at the extended visual ranges typically associated with desert environments. Use of air assaults through the depth of the area of operations to seize typically limited key terrain or road networks can enable the Combined Arms Team to counter the advantage of increased enemy ground maneuver speeds due to open and trafficable terrain afforded in a desert environment. Use of air movements to reposition supplies, ammunition, and fuel over typically extended lines of communication enables greater tempo and agility while reducing operational risk to ground logistics and maneuver units. Use of aviation reconnaissance and security operations forward or to the flanks of ground maneuver forces to identify obstacles, enemy forces, and the most suitable routes or axis of advance enables the Combined Arms Team to maintain the tempo of operations while protecting friendly units through economy of force. These examples highlight how Army Aviation's speed, range, lethality, and versatility enable the Combined Arms Team to gain, maintain, and exploit a position of relative advantage in the desert environment. Blowing dust, sand, high temperatures, reduced visibility, low contrast, and extended observation ranges all present unique challenges to aviation operations in the desert environment. Much like mountainous environments, extremely high temperatures can reduce the load carrying capacity of aircraft, requiring trade-offs between fuel, cargo, personnel, and munitions. High temperatures, along with dust and sand, increase maintenance requirements. The expansion and contraction of seals during extreme temperature swings increases the frequency of leaks and electronic component failures. Abrasion on rotor blades and other dynamic surfaces requires more frequent cleaning and can reduce component life, especially blades, bearing assemblies, and engines. Reduced visibility due to blowing sand coupled with low contrast increases the risk of brownout during takeoffs and landings, especially in larger formations of aircraft, which requires experienced crews and detailed planning in the selection of landing zones and pickup zones. During degraded visual environment operations, height above terrain and obstacles is more difficult to judge and may require higher flight altitudes and/or more experienced crews to reduce the likelihood of controlled flight into terrain or obstacles. Sensors and terminal weapon effects are also impacted by reduced visibility and surface conditions in the desert environment, which may reduce weapon engagement ranges or increase the amount of munitions expended to achieve target effect. Jungle operations. Much like in mountainous terrain, Army Aviation provides the combined arms team with a significant mobility and firepower advantage over enemy ground maneuver forces in restricted terrain characterized by dense vegetation, complex hydrography, and jungle canopy. Using air assault and air movement operations, the combined arms team can rapidly reposition forces to interdict limited enemy ground routes or seize objectives with less risk due to reduced threat, visual and audio acquisition, and direct fire engagement windows. Attack and reconnaissance helicopters and unmanned aircraft systems provide the combined arms team with mobile and responsive reconnaissance and fires to support typically small, decentralized ground operations in remote locations that may be out of the range of friendly artillery, or against enemy targets that may be more difficult to locate or attack with fixed-wing close air support. Medical evacuation and air movement of supplies and personnel enable greater flexibility for distributed ground operations in remote locations, increasing the combined arms team's freedom of action and ability to maintain pressure on enemy forces and/or sustained engagement with local populations over larger areas of operation. The employment of special patrol or fast rope insertion and extraction system, hoist, aerial delivered resupply, and paradrop capabilities enables Army Aviation to conduct infiltration and extraction of small teams, casualties, and emergency supplies in remote locations without the benefit of landing zones or pickup zones. Although dense jungle vegetation reduces enemy observation and direct fires of Army Aviation, while en route, the lack of landing zones, pickup zones, limited improved road infrastructure, and the distributed nature of small population centers typical of jungle areas of operations can result in greater predictability for the enemy to target aviation operations. Pathfinder's detailed landing zone and pickup zone reconnaissance, landing zone preparatory fires, attack or reconnaissance helicopters, and unmanned aircraft systems in support of infiltration and extraction and deception operations can mitigate this risk. The jungle canopy and dense vegetation provide the enemy with greater cover and concealment, reduce standoff ranges, and increase the vulnerability of aircraft operating at low altitudes. Jungle canopy and dense vegetation can also negatively affect terminal guidance of precision munitions or cause early warhead detonation, requiring specialized fusing or greater expenditure of munitions to achieve target effects. Jungle environments also have unique and dynamic weather patterns that can impact aviation operations. Higher temperatures and altitudes can reduce aircraft loads, which impacts ordnance carried, aircraft performance, and station time. Frequent rain showers and thunderstorms reduce visibility by obscuring terrain and obstacles, while increasing possible maintenance actions due to corrosion of aircraft components and sensitivity of electronics to humidity and visible moisture. Fog and mist in low-lying littoral areas or inland river systems, especially during dawn and dusk, can limit aviation operations at terrain flight altitudes and reduce sensor and weapon employment ranges. Low ceilings and unpredictable thunderstorms may also impact the employment of unmanned aircraft systems. Maritime operations. Army Aviation provides the combined arms team and joint force with enhanced capabilities to operate in and from the maritime domain. Army Aviation operates in the maritime domain by using sea basing as a method of projecting force into the land domain, or by using sea basing or land basing to project combat power in support of joint forces in the maritime domain. As a force projection platform, sea basing enables Army Aviation to conduct operations from over the horizon into the land domain, in support of the combined arms team, or over water in support of joint naval forces. Using sea basing to conduct air assaults, air movement, attacks, or medical evacuation from beyond the horizon into the land domain allows the combined arms team to overcome anti-access measures before seizing and establishing a lodgment. Based on the depth of anti-access measures, sea basing provides Army Aviation the ability to expand the options for entry into an area of operations due to the mobility of the basing platforms and the inherent speed, and range of Army aviation. When appropriate, continued sea basing after seizing. The lodgement can also serve as an economy of force by reducing the aviation, land footprint, sustainment, and force protection requirements. In support of joint or multinational naval forces, using Army aviation to conduct reconnaissance and attack operations over water enables the joint or multinational force commander to defeat small boat and small surface combatant threats, counter piracy and drug threats, protect individual ships or sea convoys, or attack area denial capabilities in the littorals. This enables the joint or multinational force commander to maintain open sea lines of communication, protect maritime infrastructure and shipping, or deny enemy freedom of action in maritime choke points. Rapidly changing weather conditions, sea state, low visibility, low contrast, and extended observation ranges over water present challenges to Army aviation in the maritime environment. In some maritime areas, high temperatures may cause commanders to make low decisions between fuel, cargo, passengers, and munitions. Extended operations in a saltwater environment result in increased corrosion of critical parts and will cause increased maintenance requirements. En route during low light and low contrast conditions, height above the water is more difficult to judge, and may require higher flight altitudes to reduce the likelihood of controlled flight into the water. Additionally, the size and number of the sea basing platforms directly impacts the overall size of the aviation force and the number of aircraft that can operate simultaneously. This can impact the combined arms team's ability to mass and maintain adequate aviation tempo in support of operations over land. If area denial measures are robust, standoff of sea basing capabilities will require longer routes, reducing station time in the objective unless additional forward arming and refueling points are employed on land in the area of operations. Sea basing also does not currently enable Army aviation to employ organic unmanned aircraft systems due to launch and recovery limitations. Operating from ships and other maritime platforms requires specialized deck landing and helicopter egress qualification and proficiency training, as well as over-water flight proficiency, especially during night operations. The storage of munitions on ships also requires specialized munitions procedures, training, and safety. Urban operations. Urban areas are primarily the epicenters of human activity and generate much of the friction in future conflict. Urban operations range from operations in and around small built-up areas, towns, and small cities to dense urban terrain. Army aviation can effectively overcome many of the limitations imposed on traditional ground, mounted and dismounted maneuver in this complex environment. Army aviation's inherent speed, mobility, precision fires, and persistent reconnaissance capabilities provide the combined arms team with a number of options to reduce the complexity of operations in an urban environment. The use of Army aviation to air assault small ground maneuver elements, to secure infrastructure, isolate urban areas, seize limited objectives, kill or capture high-value targets, seize key terrain, or to conduct cordon and search operations, reduces the enemy's freedom of action while economizing force and reducing risk to ground movements. The use of persistent reconnaissance and precision fires by attack and reconnaissance rotary wing aircraft and unmanned aircraft systems along key lines of communication, named areas of interest. Key infrastructure are in support of small unit mounted and dismounted ground maneuver, increases the combined arms team freedom of action, protects the force, and reduces the enemy's ability to attain tactical overmatch at the point of contact. Use of air ambulances equipped with rescue hoists to extract casualties from secured, compartmented, and congested areas enables the rapid evacuation of casualties, increasing the ground maneuver force tactical reach while reducing the requirement to secure ground movement. Using extended range and non-line of sight communications, Army aviation can provide enhanced command and control capabilities to the combined arms team through the use of unmanned aircraft systems communications relay, packages or airborne command and control aircraft to overcome the limitations of ground maneuver line of sight communications in urban terrain. Each urban area is unique and the challenges to successful aviation operations increase based on the scale, makeup, and complexity of the urban area. The availability of landing zones and pickup zones are frequently limited to sports fields, major roads, highway medians, rooftops, transition areas, vacant lots, and urban green spaces. These areas are routinely cluttered with debris or other loose impediments that can become airborne hazards during landings and takeoffs. The lack of landing zones and pickup zones also enables easier enemy pattern analysis of aviation operations to emplace ambushes or use improvised explosive devices. Significant vertical obstacles coupled with the height of adjacent buildings may limit approach and departure paths for aircraft, restrict freedom of maneuver in the objective area, and limit the number of aircraft that can simultaneously operate in the landing zones and pickup zones, requiring greater power margins to maintain aircraft combat maneuver capability. Adjacent buildings and structures also provide cover and concealment for enemy forces and extend fields of view and fire from above the landing areas. Rooftop landing areas are typically cluttered with vertical obstructions that may limit the size of touchdown areas, and based on the quality of the construction, may or may not be suitable to handle aircraft weights upon landing. The presence of subterranean structures, as well as vast road networks bounded by vertical structures, enables the enemy to rapidly reposition with cover and concealment from observation and fires. During night operations, high-intensity lighting may reduce the effectiveness of using image-intensifying night vision devices, degrading the ability to acquire obstacles to flight and other aircraft, as well as limiting target acquisition capabilities for non-forward-looking infrared-equipped aircraft. In heavily industrialized urban areas, power generation plants and other heavy industry can create localized areas of low to no visibility or layers of obscurance that impact both rotary wing flight and unmanned aircraft systems sensor employment. During attack and reconnaissance operations, high population densities in urban areas allow the hybrid threat to more easily blend in, increasing the difficulty of positive identification and increasing the risk of collateral damage during engagements. Urban landscape surfaces can increase direct fire fragmentation effects due to less blast and fragmentation absorption of soft surfaces. This may increase target effect but also increases the danger of ricochets that risk fratricide or collateral damage. During engagements of structures, shaped charge warheads on certain missile models are less effective in penetrating structures and achieving internal blast effects, which may require greater expenditure of ordnance to achieve desired target effect. The prolific use of modern communications provides the enemy with early warning of operations, limiting the advantage of surprise. Measures to consider for mitigating risk in urban areas include detailed technical reconnaissance of landing areas and obstacles, use of unmanned aircraft systems conducting persistent reconnaissance, maximizing use of precision munitions, operating during the hours of darkness at higher altitudes, conducting detailed rehearsals of actions on the objective, use of special patrol or fast rope insertion and extraction systems for small team infiltration and extraction, using common graphic control measures tailored for floor and room identification in buildings and increasing flight altitudes. Other environments. Pandemic zones. A pandemic zone is a geographical area infected with a pandemic disease. Within the pandemic environment, Army Aviation can conduct reconnaissance, convoy security, air movement of medical supplies and construction materials, air movement of medical survey or security teams, aeromedical operations, and command and control support. Key considerations when operating in a pandemic zone are the difficulties associated with decontamination or sterilization of aircraft and ground support equipment, and the limitations imposed on aircrews flying in personal protective equipment. Post-disaster zone structure. A post-disaster zone is an area that has been struck with a natural, technological, or sociological disaster. As in a pandemic zone, Army Aviation can provide a wide range of capabilities to overcome the lack of available road networks and other infrastructure impacted in the disaster zone. Key considerations include challenges to radio communications with local authorities, limited availability of host nation fuel support, damage to airfields and other supporting infrastructure, limited landing zones and pickup zones due to debris, and deconfliction with other civil or non-governmental aviation operations in the disaster zone. Chemical, biological, radiological, and nuclear environments. Operations in these environments challenge aviation operations due to the lack of aircraft pressurization and the difficulty of conducting aircraft decontamination when exposed to radiological or persistent forms of chemicals or biological agents. Air crew and support personnel performance is significantly degraded when operating in full protective posture. Key considerations before deliberately conducting aviation operations in these environments include impact to future mission support due to long-duration contamination of aircraft and support equipment. Performance impacts on crews and support personnel. Difficulties using night vision devices in addition to chemical, biological, radiological, and nuclear protective equipment. Necessity of segregating or isolating contaminated aircraft, and the impact of maintaining this equipment. Ability to spot, decontaminate aircraft and equipment to reduce the hazard of contamination transfer. To minimize the chances of being targeted by chemical, biological, radiological, and nuclear weapons, commanders should consider tactics that minimize detection of large fixed sites through camouflage or dispersion, retain mobility and the ability to rapidly reorganize, and anticipate attacks and adjust mission-oriented protective posture accordingly. Cyber domain. The cyber domain consists of interdependent networks of information technology systems and infrastructures which friendly, adversary, and other entities use to transfer information. Computer networks, cellular phone systems, social media, and other technical infrastructures are all part of cyberspace. Army Aviation operates many command and control systems through cyberspace, and commanders must protect access to critical capabilities or information. Commanders should also be aware that any public presence on social media or other cyberspace platforms may be used to help or hinder operations. This presence should be managed accordingly. Space domain. The space domain is defined as the area above the altitude where atmospheric effects on airborne objects become negligible. While Army Aviation forces carry out their tactical operations in the physical domains, they are critically enabled by space-based position, navigation, and timing capabilities. In addition, many unmanned aircraft systems, control systems, and other voice or digital communications capabilities utilize satellite or other non-line-of-sight capabilities in the space domain. Here, competitors have developed capabilities which may deny, degrade, or disrupt guaranteed access to information via the space domain. As such, commanders must plan to operate in a degraded or disrupted space operating environment. For instance, aircrews must be competent when navigating without precise global positioning system assistance. Staffs must understand how to communicate using minimum time and bandwidth, and commanders at all levels must embrace a mission command philosophy which prizes decentralized execution and disciplined initiative. Information environment and the electromagnetic spectrum. Information enables decision-making, leadership, and combat power. It is also key to seizing and retaining the initiative, and to consolidating gains in an operational environment. The information environment is the aggregate of individuals, organizations, and systems that collect, process, disseminate, or act on information. The information environment has three dimensions: physical, informational, and cognitive. The information environment is global and permeates every operational environment. It is highly congested and contested. Whenever Army Aviation supports operations in the information environment, the Information Operations Officer and the Information Operations Working Group provide critical synchronization and execution. Commanders conduct information operations to create effects in the information environment to seize and retain advantage therein. Army aviation can be employed to help create these effects. For example, Army aviation can attack physical command and control nodes or communications infrastructure, support military information, support operations in the delivery of leaflets, conduct a show of force to influence adversary decision-making. The electromagnetic spectrum is an infinite range of frequencies of electromagnetic radiation which crosses all domains. Here competitors seek to disrupt friendly access to information by interfering with or blocking certain transmissions. They may also target Army aviation units based on their unique electromagnetic transmissions. Consequently, commanders must be aware of the various types of energy radiating from their command and control systems, aircraft, and sustainment nodes. Commanders must ensure that units take efforts to mitigate or lessen electromagnetic signatures whenever possible. Section 5 Aviation and Deception Planning. As part of the information environment, it is important to consider deception operations, especially during planning. Aviation contributions to the higher headquarters plan most often consist of standard tactical tasks conducted for an alternate purpose. Deception planning is an inherent part of nesting operations with higher echelons. Deception operations are part of the development of the concept of operations within company mission planning. Products to support the higher headquarters within the company maneuver planning cell as part of understanding the ground tactical plan, and within the company protection and contingency mission planning cell. In addition to deception, planning nested with higher aviation units routinely incorporate deception planning at the lowest echelons as part of internal survivability and protection risk mitigation measures. Examples of deception in routine aviation mission planning include, but are not limited to, false landing or pickup zones, deception routes that include flying multiple alternate routes, deception fires that include deception suppression of enemy air defense, feints, or conducting false task organization movements. Deception in aviation. Mission planning both supports the higher headquarters deception plan and decreases tactical risk by improving survivability during mission execution.